Welcome back to Real Time Digital Signal Processing Lab. So, today we will see how you can use your own mobile, either it is Android platform or iPhone. You can run your some of the real time signal processing experiments on it. So, this has been developed by using Java from Arizona State University. Say they call it as what I am using today for the recording is JDSP basically. So, they have for the Android JDSP. So, you can use that, or in the normal thing they have the JDSP, basically Java based DSP project which has been developed. So, you can use them. So, what I am using, as I said, you are seeing the screen that we have the unit. So, here manuals have been given, so you can go and then check with them. So, here we will do some experiments whatever we had done the thing. So, we will see that how a signal generator is going to generate some signals. So, whether we want the sinusoid signal, rectangular or triangular or delta, exponential, any of the functions what you can select from this. So, here we will select the sinusoid. So, I will be doing the save actually and the gain is given as 1 and pulse width is 20, and we have not taken any time shift for this, and frequency in pi radians, that is 0.2 pi radians what it has been selected. So, default what it is there I am taking it. So, we are adding a block. As you can see, it is a block level design what you will be doing it. Next what we will do is I will see what kind of sine wave I am going to get it. So, we will do a plot. So, it asks add plot. So, I have added the thing. So, now the connectivity is going to be between output of the sine generation and then the plot. So, we will click on it. So, I want to see the magnitude of it. So, you are seeing the sine wave how it is looking like. So, you can have it as linear or in dB if you want to see the thing, continuous or discontinuous, what you want to see you can do it. So, linear sine wave what I am displaying it here. So, number of samples there if you want you can increase also. So, what we will do is if you click on the thing, so it will ask me to delete it. So, I can delete this. So, now what we will do is I will select one more sine generator. So, here also I am clicking on the sinusoid, save. In this case what I will do is I can select the values what I want. So, we will select it as 0.3 in this case and then save it, and then the pulse width if you want you can increase the thing. So, we will make it as 30 and then save it and then add them. So, I have 2 sine waves what I have it. Now, what I can do is I can take a sum of this and see how my output is going to look like. So, you have a adder. So, we will select the add this thing and then put it here and connect these two, and output I can put it onto the plot. So, now we will see what is the magnitude of it. So, you are seeing this is your output basically what you are getting from the two of it. So, if I want I can add one more sine wave or what I can do is I can do the filtering. So, I will disconnect this one. So, we will move it a little on the left hand side of it, so that I have a place for me to put the I can do the FFT magnitude also. So, first we can see FFT. It is FFT size is 256. So, I can add it here. So, what I get FFT magnitude and I can do the plot. So, once I click on the thing, so we will see the magnitude plot. So, you are seeing different plots for the frequencies whatever you can see this is going to give you approximately 0.2 pi. So, and then here this is your this thing 0.2 pi, and then multiple what you are generating 0.6 to 0.3 is not a multiple of 0.2. So, that is the reason why what you will be seeing here approximately 0.94 what the repetition is happening. So, now what we can do is we can create a filter in between and then see that so first I have to define the filter coefficient. So, here it is going to give me A0 is always 1 and then if I do not give any part of the thing, only B coefficients what I am going to specify. So, it is going to create me FIR filter. So, I will give the moving average basically, I can save B1 and then B2 I can give it as 0.5. We will see what is the thing is going to happen with the filter coefficients and then we will put the filter basically. So, we will add the filter here and coefficients are given from here and then input is from here and then what we will do is we will connect this to FFT here. So, now we will see what is the plot I am going to get it, magnitude plot. So, you can see that it has it is a moving average. So, you have seen that the peaks have been amplified. So, if I want I can change my this thing pulse width, I will keep it as 20 here for same as the previous one and I will increase it to this one to 0.4. I can update the thing and see what is the plot I am going to get, magnitude plot. So, you will be seeing that different kinds of it, what it is generated. So, like this you can create your own this thing, either FIR filter or IR filter, whatever filter operations you want to do the thing. So, what I will do is delete all, means the workspace is going to be deleted. There is no way you can save these workspaces in these. Okay. So, now what we will see some of the examples what we have it here, that is all of you know what is a MIDI basically. So, if I click on the thing, so you will be looking at the your piano basically. So, if you want to play and then see what is the music tone it is going to generate. So, we will only work on the black one. So, you will be seeing different tones also coming along with it. So, and you will be seeing what are the frequencies, as in our lab using the sine generation we created a Sarigama Padanisa. So, you will be seeing same kind of it what it is generated here. Okay. So, this is one of the example, and if you want to see the in between the magnitude what it will be giving up to pi what you have it. So, you if you click on the thing, so what is the peak value what you will be seeing it 0.04 pi what it is for the first white one, and so next one you can see that what is the displacement you have between the thing. Okay. And for this what is the peak you will be getting it approximately 0.05. Okay. So, this is at these distance 1/12 of the distance basically in the piano what the frequency what it will be getting aligned basically. So, this is one of the examples. So, we will delete this also. Now, other examples, so all of you know that are DTMF. So, if I click on the thing, so you will be seeing the numbers as in your telephone basically. So, I can click one of them 1, 2, 3 or whatever may be the thing. So, and then even the hash function what we have it. So, this is what different frequencies what you will be getting generated. So, if you want to see what are the things generated, so what we will do is we will put FFT here. So, add the thing with the DTMF and then we will do the plot basically. So, So, the magnitude plot what you will be seeing, because we know that it has two frequencies, one is the horizontal frequency, the other one is the vertical frequencies for the DTMF. So, you will be seeing this is approximately 0.53 and then this is 0.93. So, for one these are the two frequencies what it generated. So, if I click on now 8, okay. So, I will go back and you can check the magnitude what it has got created. So, you will be seeing that it is x axis 0.63 what you will be seeing the thing, the other one is 1.04. So, you can go to the DTMF. So, each digit what are the frequencies that get generated. So, you can map it into that. So, this is how you can play along using your mobile also, that is what I wanted to bring in. So, next is using the PZ placement, that is your pole 0 placement, you can generate your coefficient and then use it for your application. So, this is a demo what you have it. So, if I want to add a 0, I can add a 0, or if I want to add pole I can do it, or you can reset. So, this is the demo. So, I will put it as 0 what I have to add it. So, I am going to put it my 0 in this position. So, you are seeing what is the magnitude response I am getting it, and then this the frequency, that is phase what it is at the bottom what it is showing. Now, add a pole to this. So, what we will do is what kind of frequency you want to have it. So, I can put it in this way also. So, what is the thing, approximately what I am getting is a high pass filter in this case. So, by adjusting your zeros and then poles you can fine tune. So, I can add one more 0 and then I can place it here and then add a pole here, I will be fine tuning it. So, you will be seeing that what is my cutoff, how it is varying. So, I want to fine tune the thing. So, you can place the poles and zeros in whatever way you want. So, if you want to delete, if you are not satisfied with whatever the response what it is showing, so you can move them. So, or if you want to put the zeros outside, so you will be seeing that what is the phase response is going to happen and then how it is getting moved. So, this is how you can play around by placing your poles and zeros using this PZ demo. So, the next one what we have is a little bit on sound record and then player. So, what the manual says is you can play from one of the unit and then you can get it in the other unit through your Wi-Fi or whatever way it is connected. Okay. So, if you want to see the frequency response demo, so you will be seeing the demo here. So, if I want to have a low pass filter to be built in, so this is how it shows that what are the components A and B, it is a IR filter what it has designed it. So, these are the values what it has taken to get this response. So, if I want to design an FIR high pass filter, so this is my poles and these are my zeros what it is coming in my system. Okay. And same way you can define the band pass filter. So, these are the what you will be seeing poles and then zeros which is getting done. So, this is one of the thing. So, like this you have a sound player. So, if I want to do the convolution demo, I can take the thing convolution demo or you can do your own convolution. So, the demo will whether I want discrete convolution or linear convolution, what you have seen the thing. So, if I click on the thing, continuous convolution if I want to do it or discrete convolution. So, we want to have a discrete convolution. So, it will ask me signal 1 is rectangular and signal 2 is also rectangular, what it has been default what it is chosen. So, we will see what is the output we are going to have it. So, you will be seeing that this is the output Y what you will be getting your convolved signal. So, if you want to do this thing different one, we will take a triangular one and the other one also we will take a triangular and then save it, update the thing. So, you will be seeing the output is what you will be getting, 2 triangular, how you will be representing the output y basically. So, one is I can choose it as rectangular and then save the thing, update it. So, you will be seeing that wherever you have the thing convolved signal, what it shows. So, this way you can play around with the thing and then see whether your DSP concept is clear or not. Okay. So, the next one is if you want to design FIR design, you can use it, or if you want to design IR filter, you can design the thing, but the coefficients have to be given from the FIR coefficient values will be given from this block basically. If you want to design a window, you can do the window design, frequency response you can get the thing, and filter coefficients have to be fed into your filter design block basically. So, we will take up FIR filter design. So, I have asked for this thing. It has chosen in this case Hamming window, order is 8 and then the design is low pass and cutoff frequencies it is taken it as 0.2. So, we will update the same thing. So, these are the coefficients what you have it for the 8th order filter. So, now what we can do is I can generate this thing, signal generator I can use it. So, we will give it as okay, we will see the rectangular what is the output we are going to get it. Okay. So, I will add this. So, I have to select the filter, I will be selecting the filter, input from here to here and coefficients what I have taken from here. So, now because I have to see what I have got the thing. So, what we will put is FFT block in this case. So, I will add a FFT and then I need a plot. So, I will connect that. So, now we will see what is the output magnitude what I am going to get. So, we have designed the low pass filter and then cutoff frequency what it has chosen is 0.2. So, sine wave if you want to okay. So, one more plot what you want to see it, okay, what is the signal generated one with FFT what we can plot it, after the filter we can plot the thing. So, for that what it has is a junction what it calls. So, I can put a junction here. So, from here I will be taking input to this. So, from here I will be taking one of the input to here. So, I can directly plot the other one. Let us I will put a FFT there also. So, from here I will be giving to this and then I want to have one more plot. I can select it and then I will be putting, I will be connecting. So, now we will see what is this. I will see the magnitude response of this and then after filtering. So, what I am going to get is this one. So, there is no difference between the thing. So, what we will do is our signal generator directly instead of putting a FFT, if you hold it for a thing you can delete the thing, I can directly give it to the plot. So, you will be seeing that magnitude of it. So, this is a flat response what you have it, correct. So, when I pass it through the filter, because I am passing through the low pass filter the rectangular wave. So, you will be seeing that this is what the output is going to be. Okay. So, after filtering. So, I can you can keep playing with the thing. One or two more demos what I will be showing you the thing. So, if you want to do upsampling or downsampling, I have shown you one of the example, and then if I want to do the inverse FFT, both FFT and then IFFT, I can do the thing. So, if you want to pick up the peak, you can do that, and then if you want to signal to noise ratio, you can do it. So, the other one is if you want to see the spectrogram of your signal, what you can do it. So, there is one provision for long signal generator. So, if you click on it and then if you do the thing, what it says is it is a male speaker, and then the gain what they have is 1, and frame size 256 frames are there, and then overlap, there is no overlap between the frames, and then you will be seeing that current frame is there are 32 frames in it. So, I can go with the thing. So, you are seeing that where your voice is going to come. So, you will be picking up the peak of it. So, you can use that one for your usage in any of the thing. So, you will be seeing that one of the example you have is a linear predictive coding, what you can use it. So, we have a little demo on the thing. There is a LMS demo is also there for your adaptive filter. So, whatever the quantization and then pole 0 to LSF what you have the thing. So, we will take the LMS demo. So, if I click on the thing, so you are seeing that initially original filter is value has this, and then the estimated filter what you have is this one. So, by doing the next, this is the default what it has taken. So, if you give the next step, so you will be seeing that it is getting adjusted to these values whatever you had the thing. Step size you can choose between the thing. So, we will give it as 0.1 is our step size. Okay. So, then we will see that how the adaptation is going to happen. So, I will be pressing on the next step. Initially it was 0. Oh sorry, there is a mistake in the thing. Okay. So, we will so, default what it has taken the thing. So, we will see with 0.1 as a step size, it was 0.05 earlier, now it is 0.1. So, you are seeing that it is going into the negative. Okay. So, what is the thing happening? It is not reaching the 1.0. Okay. So, they are varying much away from the thing. So, by varying your step size, smaller the step size, you will be seeing that it is getting adapted, and then by making little more, you can see that it is oscillating between positive and negative side of the thing. So, this is how what you can look into the thing, and then there is a quantization setup to what this is a demo basically. So, what it has got created. So, you will be seeing that what it has is a long signal generator, and then this is a LPC1 coder basically, and then quantizer what it has in it, and then there is a filter, and it will be going for the player. Okay. So, you can see the play sound in your this thing, it will be coming out I think sound because it is taking my recording. So, here you will not be able to hear this sound. So, you will be seeing the long signal, here it has been chosen as male speaker. So, if you want to see different speakers are there, whether you want to have a music you can play with it, or a female speaker or noise or sine 1, 2 and then you can have a music and noise combined, and then you can pass it through your adaptive filter and then see that your noise is eliminated using your filtering, and then you will be getting only the music back. So, these are the playthings what one has. Okay. So, the other one is quantization, if you want to see the thing. So, we will LPC quantization. So, what it will happen is signal to noise ratio, what it is going to give you as the output. So, here it is a long signal generator, same thing what you have is a male speaker, and it has 32 frames which will be continuously played. So, and then from the junction, one is signal to noise ratio what you are calculating, the other one is you have passed it through the linear predictive coding, LPC coding, and then you have the quantization, 2 level quantization what you are doing the thing, and then you are doing the filtering from that and giving to signal to noise ratio. What we will do is we will see the thing here, that is in dB what it is going to give you. So, if you the whatever the male voice getting played is going to be showing its signal to noise ratio. So, if I play the thing, so you will be seeing continuously changing with it. So, that is from the sound recorder what you can connect with the signal to noise ratio and then see what is your signal to noise ratio is coming. So, one is the direct signal what you have taken, the other one is noise what you have whatever the output of LPC coding what you have got it, the difference between the thing that dB what it is showing here. So, this is how you can use this. Help files are there in this when you click on the thing. So, if you want you can go to the information. So, you will be having the JDSP video demo, one can look at it, and then you have the DSP with book with simulations. This has to be bought basically. So, you can web page is also available. So, if you go to the demo, so you will be seeing the, so it will show you how to go about using it with the demo. What are the things available and how is it signal generator, how you can do it, whatever demo I have seen the thing. So, you can go with this demo and then use in your own design basically. So, hopefully you will be enjoying this course. So, with this, thank you very much for listening to me. So, you can go and then play around with your mobile phone with the block level simulations also. Thank you.